12,000 years ago, the great ice sheets retreated, and Iceland was liberated from their wintry grip. Now, the effects of Iceland's volcanoes would be felt on a global scale. For thousands of years, Iceland's volcanoes were locked in a titanic battle with ice. But then 12,000 years ago, the giant ice sheets finally retreated. This would open a new chapter in Iceland's volcanic history, as they were now free to wreak havoc. But what effect would this have on Iceland and its surroundings? One of the most dramatic effects can be found in the south-central region of the island. This alien landscape is known as Larky, a row of strange craters and solidified lava flows that have bubbled up from a huge tear in the earth. A massive fissure eruption, it stretches for an astounding 16 miles across the landscape. Volcanologist Dr. Thor Thordarson is investigating Larky, the site of one of the greatest eruptions in recent history, one which would have devastating effects worldwide.
The Larky fissures, which extend from here in the southwest, continue here through the landscape as a row of cones up here through Mount Larky, which was split into two during the eruption, and continue further to the northeast all the way to the margins of the glaciers here.
Eyewitness accounts accurately date the eruption to 1783. This was one of the most disastrous years in Icelandic history. Fallout from the eruption caused harvests all over the island to fail. 75% of the livestock died, plunging Iceland into a great famine, which killed 10,000 people. But mysteriously, at the same time, the rest of the northern hemisphere reported freakishly cold weather. Averaging 2.3 degrees Fahrenheit below normal, the northern hemisphere froze over.
The North Sea along the coast of Holland froze, so people skated between villages along the coast. There was ice on Mississippi down by New Orleans in that winter.
For many years, it was thought the Larky eruption and these climatic events were unrelated. But advances in geology found it wasn't just a bizarre coincidence. Comparing eyewitness accounts with the geological remains, Dr. Thordarson has reconstructed what happened. He discovered that the eruption started with a bang on the morning of June 8, 1783. It sent rocks flying high into the air and ripped the earth open along a 1-mile tear. But this was just the beginning. 3 days later, a second eruption ripped open, then a third, fourth, fifth. In total, the earth unzipped along 10 vast tears in the crust, erupting lava continuously for over 8 months. The mammoth amounts of lava that poured out of the ground here would have buried Manhattan to a depth of 830 feet. But how an eruption on this small, remote island could cause climatic chaos thousands of miles away remained a mystery. The evidence that would link Larky with this worldwide catastrophe was locked inside these boulders.
The story is in the rocks. This rock here is part of the material, the magma that came out during the eruption. These holes are called bubbles, and they form as the magma rises from deeper in the ground and approaches the surface, and it really starts to boil. The gas, which is dissolved in the magma at depth, goes into the bubbles. Then it escapes into the atmosphere.
When this bubble rock erupted onto the surface, it would have poured gas out into the Icelandic atmosphere. Could this gas have caused climatic chaos across the globe? The identity of this gas can be found in the microscopic structure of the rock.
If you look closely at this rock, you can see a lot of white specks. These little white specks are crystals who grow in the magma at death. Sometimes these crystals, as they're growing, they will encapsulate pristine magma and bring it up to the surface.
Like time capsules, the white crystals contain untouched magma from deep in the earth, locked away since 1783. Dr. Thordarson has analyzed this magma and found it to contain poisonous sulfur dioxide. And because there was so much lava here, it would have released enormous amounts. A staggering 100 million tons of sulfur dioxide gas was pumped into the atmosphere. But how could gases released from Larky cause bitterly cold weather across the globe? The answer lay in accounts of a thick red fog reported over Iceland in June 1783. Within a few weeks, it had been blown over London and Paris, and by July, it had dispersed across the entire northern hemisphere. Scientists now know that the red fog was caused by the sulfur dioxide which rose high into the air. Mixing with water, it created a sulfuric acid haze. The haze blocked out the sun, and it sent temperatures plummeting. As a result, the northern hemisphere endured 3 bitterly cold winters, which brought spring floods, famine, and widespread poverty to Europe. Some historians have long believed that these climatic conditions triggered social and political unrest, which led to the French Revolution in 1789. But scientists now suspect Larky had ramifications even further afield. The cold temperatures in the north changed air currents in the south, causing dramatic climate changes. India was hit by a terrible drought.
People say that more than 500,000 people died from the drought in India. Also, this change in atmospheric circulation caused a very cold summer in Japan. It's cold and wet. The rice harvest failed, and the result was the greatest famine in Japanese history.
It is estimated that Larky killed over 2 million people worldwide and was one of the most devastating volcanic eruptions in the history of mankind. The evidence has proven that Iceland's recent volcanic history has had a devastating effect on the island and the rest of the world. Enormous lava fields reveal that Larky was a gigantic eruption. Bubbles in the rock indicate that huge volumes of gas were released from Larky. The white crystals reveal that this gas was poisonous sulfur dioxide. Evidence that Iceland's volcanoes caused climatic mayhem across the globe. But eruptions like Larky may not be confined to the past. Some believe that the balance between fire and ice is shifting and has the potential to propel Iceland into another hell on Earth. The evidence is mounting that Iceland has the potential to be the most lethal island on the planet. A fearsome volcanic force lies beneath it, creating powerful volcanoes capable of generating gigantic lava flows and altering global climates. Yet many of Iceland's volcanoes are covered in glaciers. Fire and ice are held in a delicate balance. Scientists fear if this balance were tipped in the volcano's favor, Iceland could become even deadlier. If the remaining ice were to melt, what effect would it have on the activity of Iceland's volcanoes? The first clue in the investigation lies in these innocuous-looking piles of rock and rubble. They're found all over Iceland, and yet these rocks don't come from a volcano. They're moraines, the geological term for rock piles deposited at the mouth of a glacier. These deposits are evidence that the glaciers are shrinking. Year by year, the glacier has melted and retreated back up the valley, leaving a moraine like this behind. Dr. Roberts has studied the Vatnajökull Glacier for the last 10 years and has noticed this dramatic trend.
The glacier has retreated at a remarkable rate. Since I've been visiting the area, I've seen tremendous changes. The ice has retreated annually at a rate of about 200 feet per year. This lake over here used to be filled with ice. I've seen the ice progressively melt, this moraine has formed, and this whole valley has become almost bare. Maybe in the next 20 years, this whole glacier will disappear and a lake will form in the valley.
Iceland's glaciers are melting at an unprecedented rate. With 5% of Iceland's ice caps melting in the last 40 years, the question that scientists are keen to understand is what effect this rapid melting will have on the volcanoes that lie beneath. The only other time that glaciers have melted this quickly is when Iceland came out of the last ice age. But what can past events tell us about the future? Geologist Professor Bill McGuire is investigating how volcanic activity changed at the end of the last ice age, and he's unearthed some surprising results.
Around about 11 or 12,000 years ago, you started to see quite rapid melting of glaciers in Iceland and elsewhere, and that triggered a recognizable increase in volcanic activity because you were removing this large mass of ice very, very quickly.
The rapid melting of ice kickstarts volcanic eruptions beneath.
Volcanic eruptions are triggered by the gas in the magma, which expands to form bubbles, and the bubbles drive the eruption. It's rather like taking the cork out of a bottle of champagne. Now, if you have a very heavy weight on top of a volcano, if there's a heavy mass of water or ice, that can help suppress eruptive activity.
But when ice melts quickly, this downward pressure is suddenly released, and that's when the trouble starts.
As the ice melts, so the pressure on the magma underneath is reduced, the gas in the magma can form bubbles, they can coalesce, and they can eventually drive the magma upwards towards the surface and trigger either explosive eruptions or effusions of lava that can spread out over huge distances.
Iceland's glaciers are melting rapidly. This has led scientists to believe that a devastating eruption on the scale of Larky could happen again.
The question is when. These are things that we have to think about and try to prepare ourselves to deal with if they happen in our lifetime. Is it possible that we can get another eruption like this in Iceland? Definitely.
The investigation has revealed how the vast and violent island of Iceland was formed. Cracks in the Thingvellir Plain and traces of chemicals in the rocks revealed how the Mid-Atlantic Ridge and Hotspot joined forces to create a colossal volcanic force. Massive fissure eruptions ripped the land open. Hemorrhaging millions of tons of lava, Iceland rapidly formed. Deep northern fjords were evidence that a giant ice sheet eroded the land and entombed the volcanoes, locking fire and ice in a titanic battle. Boulders strewn in an ancient valley revealed how fire emerged victorious, unleashing cataclysmic floods. And specks of sulfur in the rocks showed how Iceland's volcanoes have the potential to cause global destruction. Now, glaciers melting above some of the world's most deadly volcanoes are increasing the threat of future eruptions. Over the last 20 million years, Iceland's almighty volcanic force has created a vast alien landscape. Volatile and unpredictable, it may one day unleash a massive eruption which could devastate both Iceland and the wider world beyond.